Welcome back to the chapter Squares and Square Roots for Standard 8, and this is part 2. So in the last video we discussed about what is a perfect square. Now we will learn the properties of a perfect square. So now we will learn some properties by which you can say whether it is a perfect square, it can be a perfect square or not. So a number having 2, 3, 7 or 8 at the units place is never a perfect square. So before that, let us go through this table. I have written the squares of all the numbers from 1 to 20. So 1 squared is 1, 2 squared 4, 3 squared and 9 and so on. Now see the unit digit in all the numbers. So here for 2 it is ending with 4, for 3 it is ending in 9, and with 4 it is ending in 6, and for 5 it is ending in 5. Similarly, and 6 is 6, 7 is 9, 8 is 4 and 9 is 1, and 10 squared is 100. Now here if you see, now 11 squared again it will end with 1, and 12 squared again like 2 it will end in 4, because 12, if you see 12 into 12, so 2 first the number in the unit space is 2 and 2, so it will become 2 into 2 4, so automatically it is going to end in 4. Similarly 13 squared will end, so it is 3 is at the unit place, so it will end with 9. So if you see, so these are all perfect squares. In these numbers you can see you don't have a number ending with 2 or a 3 or a 7 or a 8. You have all other numbers apart from these 4 numbers. So if you get a number which ending with 2, 3, 7 and 8, it can never be a perfect square. So the numbers ending with 0, 1, 4, 5, 6, 9, 0, it doesn't mean that all those numbers ending with these numbers are perfect squares. So it does not necessarily mean that it is a perfect square. For example, if you see 64 is a perfect square. 64 square you can write it as 8 squared. So 64 is a perfect square. But 74, now this is ending with 4, but 74 is not a perfect square. Similarly, if you see 100 is a perfect square, so 100 can be written as 10 squared. So it is, so this is 10 squared, so it is a perfect square. So for 64 you can write it as 8 squared, but 200 you cannot write it, though it is ending in 0. Here it ending in 4 does not mean it is a perfect square. So what do you understand from this? Now we are only, the property is, if it is ending in 2, 3, 7 and 8, you can definitely say it is not a perfect square. So the numbers ending with other digits are necessarily not a perfect square. Now coming to the second property, the number of zeros at the end of a perfect square is always even. For example, 100. You see there are 2 zeros at the end. So 100 you can write it as 10 squared. So 100 is a perfect square. Similarly here it is 10,000, you can write it as 100 squared. So you have 4 zeros that at the end, so it is even number of zeros, so this is a perfect square. But that does not mean that 200 again it is having a even number of zeros, but it is 200 is not a perfect square. And if it is ending in odd number of zeros, again it is not a perfect square. So from this we understand that if it is ending with 3 zeros, definitely it is not a perfect square. If it is ending in even number of zeros, It can be a perfect square or it need not be a perfect square. But if it is ending in odd number of zeros, you can definitely say it is not a perfect square. The squares of an even number is always an even, and squares of an odd number is always an odd. So just go through this table. Even numbers, if you see, it is 2 squared is 4, 4 squared is 16, it is an even, 6 squared is 36, 8 squared is 64, 16 squared is 256. So all are even. Here odd numbers you take 3, 9, 5, 25, 9, 81, 15, 225, 19, 361. So all the squares of even numbers are even and squares of odd numbers are odd always. Now the another property is, this is also for to say whether that it is not a perfect square. So if a number is divided by 3 and if you get a remainder of 2, then you can 100% say it is not a perfect square. Similarly, if a number is divided by 4 and you get a remainder of 2 or 3, then again it is not a perfect square. Now coming to the next property, if n is a perfect square, you can say 2n can never be a perfect square. For example, you know 25 is a perfect square. 25 you can write it as 5 squared. So it is a perfect square. So you take 2n, so 2 into 25 is 50. 50, you know if 50 is not a perfect square. So if n is a perfect square, 2n can never be a perfect square. This is a very important property. A perfect square can never be negative. Why? Because you have to multiply with the same number, minus 5 into minus 5. You always get a minus into minus is always positive. So you get 25. If you multiply with 5 and 5, you again get a positive number. So a perfect square is always a positive number only. It can never be negative. The next property is sum of first n odd natural numbers is equal to n squared. So here you don't have to do the addition. Without that you can easily use this property to find the sum of the first odd natural numbers. See, what does this mean? It is from the first n odd natural numbers. So it is from starting from 1. The first natural number is 1. So it should be odd. So 1 plus 3 plus 5 plus 7 plus 9 if you want to do. Now you count how many natural numbers are there. It is 1, 2, 3, 4, 5. So it is n squared. So 5 squared equal to 25. If you add and see, 4, 9, 18 plus 7, 25. You get it. Now similarly 1 plus 3 plus up to 21. So here instead of adding, you can find number of terms here. If you add 1, 3 up to 21, you will get 11 terms. So 11 squared, it is 121. You can try it and see whether you are getting the answer. You add 1 plus 3 plus 5 plus etc. till 21 and see whether you are getting the number 121. Now we have another important property, that is Pythagorean triplet. So you have heard about Pythagoras theorem in triangles. It is somewhat similar to that. Here again triplet means it is a set of 3 numbers. So 3 numbers, let it be m, n and p, and they are natural numbers. So if you are able to write the sum of the squares of 2 numbers is equal to the square of the third number, then it is called a Pythagorean triplet. That is, if you are able to write m squared plus n squared is equal to p squared, then you can say m, n and p are Pythagorean triplet. So see this example 3, 4 and 5. Let us find the sum of the smallest 2 numbers. So 3 squared plus 4 squared, you will get it is 9 plus 16, 25, that is equal to 5 squared. So you are able to write it as 3 squared plus 4 squared equal to 5 squared. Similarly, here also 5 squared plus 12 squared is equal to 169. You can write it as 13 squared. And similarly this number also. So these numbers form Pythagorean triplets. There is a standard form to find Pythagorean triplets. 2m, m squared minus 1 and m squared plus 1 will form a Pythagorean triplet where m is a natural number and m is greater than 1. So you can find any number of Pythagorean triplets. Now you can put m is equal to, you cannot put m equal to 1, you have to, it is m greater than 1. So m is equal to 2, you put, so 2 into 2, 4. Then m is equal to 2 squared minus 1, that is 4 minus 1 is 3. And again m squared plus 1, 2 squared plus 1 is 5. So 4, 3, 5 is a Pythagorean triplet. Similarly, you put m is equal to 3, you get 2 into 3 as 6. M squared minus 1 will become 9 minus 1, 8. And 9 plus 1, 10. You can check it, you get 36 plus 64 equal to 110 squared. You cannot put m equal to 1 because if you put m equal to 1, you will get 2 into 1, 2, then 1 squared minus 1 will become 0 and again you will get 1 plus 1 equal to 2. So it is 2 and 2 are same numbers. So it is not distinct numbers. M, N and P should be 3 distinct numbers, then only you can say it is Pythagorean triplet. So here when you put m equal to 1, you don't get 3 distinct numbers. So that's why we take m greater than 1. So using this standard form, you can find any number of Pythagorean triplets, just simply putting m is equal to values greater than natural numbers greater than 1. I'll see you all with the chapter with the square roots, the concept of square roots in my next video. So meet you all. Till then, bye.